Okay, my friends, Easter, and I did a post on the light that is the three separate sets of light that is talked about in some of the ancient scriptures talking about Jesus, and that he was light, and he was three different types of light. So I showed this video today, and I got a lot of responses, and one of them was this. Because I've been doing a lot of physics, and I want to understand light and electricity and electrons and all that business, how chemistry, bonding and all that. It's pretty complicated, but I think I'm homing in on it, and I think there's only two particles. Now, here's the bottom line. This was sent to me by, I don't know who, to be perfectly honest with you. It came in just as some pictures. Now, what do you see here, though? I'm seeing something extremely high energy. That's very high energy. That's a blue range of energy, and there's no other colors here other than the blue. So that's kind of strange, first of all. Now, secondly, it looks like it started off as a round ball, like a sun, like our sun, and came through here, and I believe this accelerated it so that it became crashing into the atmosphere down here, causing it to be seen from this specific curvature here, which is like a half a venturi. I've seen this. I understand these venturis pretty well now, and that's a half a venturi. I had Renz, a friend of mine, held his finger up or his thumb up, and that's what this person was doing, was trying to recreate it. I'll show you, and they did a fabulous job. I tell you, this stuff is, I'm getting a lot of responses. A lot of people are paying attention now. So we have a high energy particle. Why? How come that's so high energy? And where is it coming from? Because here's the key that's a killer. There's the sun. What the hell's that doing? This is what I've seen, some of these that are coming down. I can't account for them. I mean, absolutely enormous. Now look at this thing. Here's what he got from the sun. Now the sun is a full spectrum light emission source. And here it is. There's all the different colors of the rainbow cascading off of his finger. And these are the white Higgs coming across. And these are the colored portions of the Higgs. Looks like to me. And like I say, that to me has to be the sun. Now, what the hell is this? That's the one that I don't understand. I really don't understand. I know it's coming out of here, but what would make that? What would make that thing come out of there if the sun was in that position? I mean, he's not holding his thumb up this way, I don't think, and it's coming this way. It looks to me like it's coming this way. Well, I know it's not coming this way because you'd see it up here coming down. It's obviously there. There's no other way you can look at it. But it's got me intrigued. I can tell you that. But and he's got a pretty good array of colors here. And the reason that they're splayed like this, I think, is because it's coming through the leaves. If it wasn't coming through those leaves, I think you would see the lepton colors splayed out in their correct colors. The blue over here, and you lose the blue quick because it impacts hard. And then the green, and then the red goes for long distance. So, a little more on light, and we're going to get real deep into this, because all this is electrons and positrons crashing into atmosphere. And the reason they're crashing to this Earth is because of the magnetic pull of the Earth. That is gravity. The Earth pulls positively all electrons, and everything there is has electrons. Everything has electrons. Light has electrons. Electricity is all electrons. Every mass is coated with electrons and flooded with electrons. That's why it is sucked to Earth. It's the electron drawing itself to the Earth. That's the positive pull of Earth. And that also has an extreme effect on light, because that is a polar particle. Okay, my friends, it's Roger once again. I'm talking about light and all the different particles in light. Now, if you've been paying attention, you got to start at the beginning and keep an eye on this, because my claim is that all protons and neutrons are literally made up of tiny little bits that are the same size as the electron. So it's 1836 in a proton, 837 in a neutron, and 1 in an electron. Now, that's what the tiniest photon looks like. These are quarks. And then the next size up is just more of these particles, and it's green. And then the next size up is only more of these particles, and it's blue. And the reason there's different colors is because they have a different impact. They have a different power. The red can never, ever, ever displace an electron. You can shoot it as fast as you can make it go. It cannot displace electrons. The green on its upper end is capable of possibly moving electrons out, and the blue will move them every single time. If you just nudge it against something, it'll push an electron away because it's massive. That's like a ping pong ball, that's like a bowling ball, and that's like a cannonball. All right? Then when you go up in heavier particles, 8, 10, 12, 100, 200, 500, you're in the UV, X-ray, gamma, all those dangerous radioactive heavy-duty rays that are going to literally getting ready to explode, because they want to be at the proton-neutron weight of 1836, 1837. That is resonance. All right? So these are photons, and that is what an electron is, and it makes up half of a photon. A photon is just like this. It's an up and a down and an up and a down. It's an electron and a positron. All right? So let's talk about quarks. All right, here's the quarks. Let's see what they have to say about them. Quark is a type of elementary particle. It means it's the smallest little bitty particle, and a fundamental constituent of matter. It means it's in every bit of matter. These quarks. Quarks combine to form composite particles called hadrons. That means they're just bigger and bigger bits. The most stable of which are protons and neutrons. Those are little particles building up bigger and bigger, bigger, and they call them protons and neutrons, and they refer to them as hadrons. I don't know why. The components of atomic nuclei. These are the things that are inside of the atomic nucleuses of all atoms. All atoms. Now, due to a phenomenon known as color confinement, red, blue, green, quarks are never directly observed or found in isolation. I say that's wrong. I will show you them in a moment. They can be found only within hadrons, which include baryons, such as protons, neutrons, and mesons. These particles exist within all particles, and they are just bigger particles. There's one that's the smallest one, and the next one is a couple of those together, and the next one is a couple more of those together. All right, so let's look at that. Okay, now we're going to get in a little deeper. Now, I'm claiming these quarks add to make protons and neutrons. Yes, they just keep adding together until there's enough of them for a proton or a neutron. And that's 1836 and that's 1837. Now, they all have a charge. This one has a zero charge, and that one will have a zero charge too. It presents as a zero charge, but they do have a charge. If you broke them apart, they will have a bunch of charges in there. They do have a mass, obviously. They're chunks. They have a color, red, blue, green, red, green, blue, I mean, and they have a spin, and they have sizes. Now, this right here is the base of all matter in the universe, I believe. Protons are made of this, neutrons are made of that, electrons are made of half of this, positrons are made of the other half. Okay, so here's your electron. You got a positive tip and you got a negative tip, even though it's an electron. The electron is not just totally negative. And I will show you in the light experiments that I can say this because of photons we see are back to back. I have one of these and one of these. It has a plus minus, and down here another plus and a minus up here. So there's a block of them in every photon. And half of that would be an electron, because the photon is not influenced by a magnetic field, so it doesn't have a polarity, which is the case if you had this. It's not polar because the whole thing is one big chunk of matter, positive, negative, so it's not like got one polar side. When you get to this, you have polarity, a positive end and a negative end. This one has a negative end and a positive end. I can't account for that. They're the same size. It's the same charge, only one's up and one's down. One appears to be spinning with a right-hand spin, the other one appears to be spinning with a left-hand spin. I don't understand it. I really don't understand that, to be perfectly honest with you. That's the thing that bothers me. But there is an upspin and a downspin. And here's what happens. When you have the two of these together, you got an upspin and a downspin, so you're zero. But here, when you go to green, you have a six-banger. So now you have two sets going in the up and one set going in the down, so you have a 1/3 plus. Okay, now this one has, so because you got two pluses to one minus, so you got a 1/3 plus. This one has two minuses to one plus, so you got a 1/3 minus. Then you go into the bigger ones, the halfers, and you got half minus and half plus. And you could jiggle these around, and then you get bigger and bigger and bigger and bigger, and you get chunks and chunks and chunks and chunks. Now, these two together do not annihilate each other. A positron and an electron join together to make a photon. All right? The three colors all together make white. And I told you, I'm going to show you the leptons and the white Higgs. Exactly what they say should happen. And this is created when you use a half a Venturi. It literally pulls the colors apart. And they say that's what happens. If you drag the colors apart, they will separate, and they did. And they display themselves, and they show the white Higgs, which is also what they claim should happen in this event. And there's the event I'm talking about. If you can see that's blue, then a little bigger stripe of green, a little more in the red, blue again, green, red, pulling itself apart, ripping itself open, because it's being forced by a half a Venturi. This is full spectrum light from the sun. Full spectrum. That's just a thumb, literally a thumb, and light being ripped off of that thumb as a half a Venturi. If there was another thumb on this side, you would have a full Venturi, and these things would be flooding through here in the middle. They'd all be white. But this is a half. And this side is ripped, and this side is sending off the Higgs. This is a different situation where there's a Venturi, a complete Venturi, and it spits out Higgs fields everywhere. And it created one reverse spinner, a white one up here, that was the only one in the field. And that ended up colliding with a standard Higgs and creating that little particle. I don't know what that is, but it is smaller than light. These Higgs fields are a product of red laser particles. That is as well. That one appeared to spin backwards, and that's the interaction. I don't know exactly what to make of it. These are the particles as they come out of the accelerator. So we're seeing a lot of very interesting characteristics. All these white particles glowing in the fields are the ether particles, which are nothing more than free electrons or photons. I'm not sure whether of the structure of them at this point, but I think they're electrons because I think they're the ones that collect on you as static and discharge to ground, floating in the air, attached primarily to water molecules, which are highly polar molecules, and there's a lot of moisture in virtually all air. Those particles concuss and glow as this enormous particle comes through the air. That particle is light And that particle is enormous. It's about the size of a basketball. I'm not kidding you. These things are huge. The region that they concuss through in a laser like that, you don't see it until you use the special type of phones that have these camera capabilities, and in a darkened room, and they show up. The cameras pick it up. And they pick up details that are incredible. All these different polarities from Cherenkov radiation after it has been accelerated. Cherenkov coming out towards us now. Boson particle, little fibers, spinning away, spinning through space. When they crash into unrestricted space, they create these elegant little polarized fields. And some of them are different colors than other ones. You say, why? Because they were all red. They should all be red again. And they will. And the reason that these are different colors now is because they are coming through at different intensities. This one is probably coming straight through the center. The other ones are coming through at a little bit of a different intensity on the sides. And that means the impact that will be felt by that particle when it hits the unrestricted space will be more than particles that did not get through there in the most efficient manner. So they're going to glow a little less. They're going to have a little less frequency to them. And then they're all going to settle down to their own frequency. Because the frequency is a product of the particle itself, which they're all the same. But it's also a particle of the speed at which that particle is impacting the oncoming ether. And that's the reason that one there is purple. And these are different colors. And they're all going to settle down to red. So, there's a lot to talk about.